Welcome back to Generative AI 101, the podcast where we transform the intricate world of AI into something that you can actually make sense of. I'm Emily Laird, your guide through this wild and wonderful digital landscape. Today we're diving into Recurrent Neural Networks, or RNNs. Not like our last episode, CNNs. We're now at RNNs. The neural networks that have a knack for remembering the past and predicting the future. Ready for a journey that's part Groundhog's Day, part Nostradamus? All right, let's get into it. Welcome to Generative AI 101. All right, let's talk RNNs. Imagine you're reading a mystery novel. You've got to keep track of clues, characters, and plot twists that span across hundreds of pages. RNNs are like your super intelligent reading buddy, remembering what happens in previous chapters to make sense of the current one. They're designed to process sequences of data, making them perfect for tasks where context matters. Think text, speech, or any data that has a temporal dimension. So what are recurrent neural networks? RNNs are a type of neural network where the output from previous steps is fed as input to current steps. They're like that friend who remembers everything you ever said and reminds you of it, kind of like a bad ex, right? This makes them ideal for sequential data, where understanding the order of information is crucial. There's some key components of RNNs, so let's start with recurrent layers. These layers are the center of RNNs. They have loops that allow information to persist. Imagine a chef making a multi-course meal, constantly tasting and adjusting each dish based on how the previous one turned out. That's how recurrent layers work. They're always considering past inputs. Then there's hidden states. These are like the RNN's memory bank. They store information about previous inputs, which helps in making sense of the current input. Think of them as the notes you took while binge watching a TV series, helping you keep track of the plot. I'm talking Vanderpump Rules or 90 Day Fiancé. You're constantly jotting down the chaos. Then we have weights and biases. Just like in other neural networks, these parameters are fine-tuned during training to optimize performance. It's like a DJ adjusting the bass and treble to get the perfect sound. So let's break down RNNs with an example that's not just about cats and dogs. Imagine you're a sports commentator. You need to provide a play-by-play account of a basketball game. RNNs are like your co-commentator who remembers every play and uses that memory to give context to the current play. When the star player makes a shot, the RNN recalls the player has been on fire tonight, adding depth to your commentary.
And that's his 10 shot tonight. He's unstoppable.
It's all about understanding the sequence of events and making sense of the correct moment based on past information. So let's look at some real-world examples, because RNNs aren't just for hypothetical sports commentators. They're used in a variety of fascinating applications. Think language translation. RNNs can translate text from one language to another by understanding the context of the entire sentence. It's like having a multilingual friend who doesn't just translate words, but the meaning behind them. Then there's speech recognition. Virtual assistants like Siri and Alexa use RNNs to understand spoken language. It's like having a butler who not only listens to you, but actually remembers your preferences over time, getting better at serving your needs. Ever notice how your smartphone suggests the next word as you type? That's RNNs at work, predicting what you're going to say next based on the context of your current message. It's like having a friend who finishes your sentences. Financial forecasting is another way RNNs are used. They analyze sequences of financial data to predict future trends. It's like having a stock market guru who's always one step ahead, making sense of the market's ups and downs. Of course, RNNs, like most of us, have their quirks. They suffer from what's called the vanishing gradient problem, where they struggle to remember information from too far back. It's like trying to recall what you had for breakfast 3 weeks ago. Not easy, right? To tackle this, we have variants like LSTM, or long short-term memory, and GRU, gated recurrent units, that help the network remember longer sequences more effectively. In summary, recurrent neural networks are the memory keepers of the AI world, designed to handle sequential data by remembering past inputs to inform current decisions. They power everything from speech recognition to predictive text, making our interactions with technology smoother and more intuitive. That's all for today's episode on RNNs. I hope you enjoyed this deep dive and had a few laughs along the way. If you've got questions, thoughts, or just want to connect with me, find me on LinkedIn, Emily Laird, Laird. Let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about recurrent neural networks now than you did when you arrived.